Welcome to lesson 4, in organizations, where we're going to be looking at business intelligence. So, in every organization, right? So, business intelligence is one of the processes in most organizations because it has to do with the process of collecting, storing, and analyzing data from your business operations to make informed decisions, right? So, instead of guessing or relying instinct, you use fact and numbers to guide your decision. So in many different organizations, right, we normally use the data of our businesses to actually make decisions, right? So most organizations use their data, and also most organizations use existing data to build the model in order to make intelligent decision. Right? So in this lecture, we're going to learn how we're going to be learning the introduction to analysis and the problems that involve in analysis, right? So the next slide we look at the components of the business intelligence. We found that in the previous lecture we look at the relational database management system, and we've seen how we can be able to build tables, structured data, and how we can be able to relate them, right? So here in the key components of business intelligence, right, we have four components of business intelligence, which are the data collection, data storage, data analysis, and reporting. Now, all this can be done without the use of data, and the data, right? The organizations already have the data set that does this, right? There are some that makes use of the structured data that's involved because it's collection of data, because for every transaction, right, the organization keeps all transaction record, right? Like you can see, for example, here, gathering information from different sources like the sales record, customer feedback, inventory levels, right? So it depends on your organization. But one thing for sure is for everything going on in the organization, right, it is very appropriate for the organization to keep track of every activity going on so that the organization can use that to make proper decision making. Right? You can see where we have the data storage. It has to do with keeping this information in a place where it can be easily accessed, like a database, which we did in our previous lecture. Then we can use this to actually make data analysis, like looking at the data to spot trends and patterns. Well, this is what we're going to be looking at here in this lesson. We're going to be looking at the problems involved in the analysis, and we're going to be looking at some of the tables that you can see and then identify the problems and how to solve that. Right? The reporting has to do with presenting this information in a way that is easy to understand, like in chart or dashboard. Now, in the next place here, we're going to be understanding what analysis means, right? So now that we have got all the data, right? Like now that all the organization has collected all the data set, right? So we want to dig deeper, right? We want to dig deeper. So analysis is like the detective work you do on your data. It is about not just knowing what happened, but understanding why it happened and what might happen next, right? So let's look at the type of data we have in the data analysis, right? So we have two type of data, which is either the structured data and the unstructured data. Now, the structured data make use of the columns and rows, right? So structured data is highly organized and often found in database spreadsheets or tables, right? So it makes use of the tables and rows, while the unstructured data lacks predefined format to structure, right? So such as text, images, videos, or audio files. Analyzing unstructured data often involve more complex technique, often involve more of natural language processing techniques, right? But in this lecture, we're going to be looking more on the structured data. We're going to introduce you guys more on the structured data and the problems that involve in structured data. Right. So before that, we need to understand the variables. So we have two type of variables, which are the dependent variables and the independent variables. Right. So the dependent variables, which is a target variable, is what we are trying to predict or explain. So in the context of regression, this is the outcome of result that is influenced by other factors. It is also known as target variable or response variable. Right? This is merely so we're going to be giving an example there. You can see that we have this is a structured data set, right? So you can see that we have attributes here that describes the characteristics of this table or the properties of this particular table, right? So this table has this a customer shown table which shows we keep records of customers leaving and customers staying in the particular organization, right? So you can see that the customer ID, age, gender, tenure, monthly charges, total charges, and contract types, these are all independent variables. And you can see the shown, which has two categories, yes or no, right? So yes or no, just two categories. Now this is a binary classification which we'll look at next, right? So this is the target variable, or you can call it the response variable, or you can call it the dependent variable, right? So now the independent variable, which is a predictor, the independent variable are the factors that you believe have an influence on the dependent variable, right? So these are also known as predictors, explanatory variables, or features, right? So these variables are used to make prediction or explain changes in the dependent variable. Now we have so many problems. We have different type of problems that we can actually identify when we look at the data set in the using the structured data. So the first one here is classification problem, right? Let me call this one binary classification problem. Now this problem assigns data points into predefined categories or classes. So example is predicting whether a customer will shun or stay based on the usage patterns and demographics. So if you can see here, right? So this is a structured data, and you can see that the dependent variable only have two categories, right? So this is actually a binary classification problem, which is actually yes or no. So we have so many algorithms that we can use to solve this problem, and this algorithm in machine learning is classified into two into we can use a supervised machine learning algorithm, supervised machine learning technique, the unsupervised machine learning technique, right? But in this one, the supervised machine learning technique is most appropriate to solve this problem. Now, some of the algorithms to use to solve this problem, right? Like you're building a model, you want to build a model to use this data set, you train that model on this data set, so that when a new employee is coming in, that the machine can easily predict if the customer, sorry, a new customer coming in, right? So the machine can easily predict if the customer is likely to leave your organization or stay in your organization, right? There are some other problems where you can be able to check the descriptive analysis to know what age group of customers leaving your company and so many stuffs like that. Right? Exploratory analysis when we're looking at the correlations and stuff like that. Right? But in this class, this is not a data analysis class. This is just an introduction class. This is that computer organization class where we just need to know understand the basic rather than going down deep into the analysis class. But if you're interested, you can look at my data analysis videos to be able to understand how this works. Right. So the techniques to solve this are the decision tree, random forest, support vector machines. Right. These ones are supervised machine learning technique. Right. So let's look at the second problem, which is the multi-classification problem. So this is the description which I've explained, right? So let's look at the multi-classification problem. Now the multi-classification problem, looking at that set, right? So if you see the target variable, now this is the target variable, this is issue type, you will notice that we have more than two categories. You can see that we have billing, technical account management, billing, technical account management. So here we have three categories. So this is no longer a binary classification problem, right? So this becomes what a multi-class classification problem. And this problem is similar to classification, right? It's similar to binary classification, but with more than two categories. Similar to binary classification, but with more than two categories. You can see that the spot issue like classify the type of customers issued based on the features provided. Now technique, we can be able to use the logistic regression, right, which we explained this in our data analysis class, how this algorithm works mathematically, theoretically, and how we can apply them practically to solve this problem. And we also have decision tree, we have random forest, we have neural network, and we have so many of them that we can actually use to solve this problem. Right? You can see that the ticket ID, the customer age, the issue duration, the contact method are all the independent variables. Right? Now, we want to look at the data types, right, where we have the discrete, the continuous, right, variable, but we won't look at that in this class, right, because this is not data analysis class, so we won't actually focus more on the, we'll focus on continuous or discrete variables here, right. So now let's look at the next problem. So the next problem here is the regression problem, right? So if you have a data set like this, where the dependent variable is continuous, you can see that the dependent variable is numerical and is continuous, where you can see it is in prices, where we have 300,000, 400, 250, and so on and so forth. So it's a continuous, where the categories are continuous, right? So you should all know that this problem is a regression problem, right? So it has to do with predicting a continuous numeric value based on input variables. My example is forecasting sales revenue for the next quarter based on historical sales data, right? Sales data, market spend, or economic indicator. As you can see, these are all independent variables like the house ID, the bedroom, the bathroom, the square feet, the age of houses, the garage, right? Then this is the dependent. This is the dependent variable, right? Which is continuous. So this is not actually a multi-classification problem. This is not actually a binary classification problem. So this becomes a regression problem because the target variable which we're trying to predict is continuous. Now the reason for this is when we train our model based on using this data set, right? So in tree model using data set. So any new input of houses coming in, right? The machine can be able to predict the new price for that new houses. And now there's every tendency that the machine may not predict well if you don't have enough data set, because the data set to be able to predict well should be very, very large so that the machine can be very, very intelligent to predict new prices for new house, right? Or new, right? For new house, right? Based on the futures that you will key in, and the machine can also predict the price that is suitable for that new house. So that is the reason why we're having the asset in order for us to make proper decision, right? Proper decision making. So let's look at the fourth one here, which is a time series problem, right? So a time series problem, looking at this data set here, right? When you see a problem where you're trying to like predict the future of what will happen, maybe in the next 5 years, or the next 2 months, or the next 3 days, or the next 4 days, right? Or the next five, or the next 6, 10 years, what will happen in your business in order to be able to prepare for the worst or prepare for the best thing to happen in your business. So this is actually a time series problem, right? You can see the data set here where we have the month and the saves. The month, where we have the month, you can see this month, keep track of the date, right? So this becomes a time series. I would say you can see analyzing and predicting data point collected or recorded at a specific time interval. So the only attributes that we have here that keeps time interval here is a month, right? So if you're trying to predict what will happen here, you can see for example is forecasting stock prices, analyzing seasonal sales, or predicting electricity consumption. Right. So you can see this data set here, it has a month. So this is what we use to train our data sets. So when a user key in, okay, what will happen in the next 5 years? Now the machine we use these that's been trained on to be able to predict what will happen based on this existing data set. And the technique to use here is autoregressive integrated moving average. That's one of the technique, right? Which we'll learn that in our data analysis class. We have the exponential smoothing, and we have the long short-term memory network, and so many of them that we can use to solve the time series problem or to build our model to be able to predict right time series, right? So let's look at, we have seen the four common problems in structured data. So here we're going to be looking at one of the Common problems using unstructured data, right? So unstructured data mainly involves more of information extraction, like image processing, right? And video processing, so many of them. Right. So this one is just one example, one problem of unstructured data. Right. So this one of this falls under information extraction. Right. So you can see that the problem is determining the sentiment of emotion, determining if a text, right? The key stuff is determining if a text is either positive, negative, or neutral. Now, so when you can see that example, you can see we have this data set here, right? I have this data set here. You can see that the first sentence here is, I absolutely love this product. It is amazing, right? So you can see the data set is already classified. This sentence is classified as positive. Now, this is the worst percentage I've ever made. This is classified as negative. The service was okay, not great, but not terrible. This is classified as neutral. Now let's assume that a basic way to actually build a model to predict the next input sentence, okay, right, is to check the probability of each word. Like if I have a new input sentence coming in like this, like for instance, I said maybe I like um I like services. Let's say I like service, right? Now this is a new input coming into the system, right? So the system doesn't know what this is classified into, whether it's negative, positive, or neutral. But you as a human, you know this is actually positive. So the thing the system doesn't know, what the system actually do is tokenize each of the word. Tokenization, like you separate each of the word, right? So I is different, like is different, service is different. So what it does is it look the probability of where I occurs. If I occurs more in positive, then I becomes what positive. If like occurs more in positive, like become positive. If sales occurs more in positive, sales become positive. So if you do the sum, you see that this is actually positive. That is just the basic of sentiment. So there are more technique that involves in that, right? So which I've made videos for that, how we can be able to do the same mathematical, theoretical lecture and also the practical lecture and how we can be able to solve problems in sentiment analysis, right? So so let's when you combine business intelligence with analytics, you get a powerful toolkit that help you provide smarter business decision. Right? So you're not just looking at what happened in the past, but you're also using that information to predict the future and plan your next move. So let's look at a problem here. Let's look at an accessory problem. Okay. So we have understood what is business intelligence and analytics. We understood the types of variables, which are the dependent and independent variables, right? Also the type of problems in analytics, right? Which the structural problems and the unstructured problems. Then given it that, then let's solve this, right? Now let's solve this descriptive using the descriptive analysis, right? So given the data set of monthly customer churn rate for a company over the past year, now calculate the following statistical measures: mean, median, mode, range, standard deviation, maximum, minimum, first quarter, second quarter, which is the median, and third quarter, right? So let's solve this descriptive analysis and let's see how it works, right? So this is just a basic descriptive analysis, right? So we're going to solve it theoretically. Right. So we have given a data set here. You can see this data set here that has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 attributes. So out of the 8 attributes, one is a dependent variables, right? One is dependent. So you can see that it's shown here. You can see the shown has two categories, right? So these are the 8. So we are told to, looking at the question here, we are told to given the data of money, this for a company like this, calculate the following statistical measures mean this. So what we're trying to do is we want to calculate for age, we want to calculate for tenure, although we are not giving specification of what to calculate for. But here we want to calculate for the age, right? We want to calculate for the tenure, we want to calculate for monthly charges, calculate for this. But because there's no time here, we're going to do for age. So if you can do for age, you can do for tenure, you can do for monthly charges, you can do for total charges, right? So let's do this. Now the first thing to do is to calculate. We understand what mean is. So mean has to do with the average, right? So for the age now, for this attribute, age, right? So we are going to calculate the total number of the ages that we have here, right? the sum of all the ages here divided by the number of ages, total number of ages. So the sum of the ages here, which is 34 plus 45 plus 23 plus 50, divided by 1, 2, 3, 4, divided by 4, will give you what? 38. So the median is to get the mid age. And to get a mid age, the first thing you need to do is to sort the ages in ascending order. So sorting the ages in ascending order will start with the smallest, which is 23, then followed by 34, followed by 45, and followed by 50. Then we get the middle. You can see that in this median here, we have total number of number four numbers here. 1, 2, 3, 4, right? So to get the median here, because this four is an even number. So since 4 is an even number, you take the two middle number and divide it by 2. But if it's an odd number, you just go straight to take the middle number, right? So now to find the median here, we have, since this is even, is 34 plus 45 divided by 2, which is 79 divided by 2, we got 39.5. So the next thing to find here is to find the mean, the mass, and the range. So we all know that the mean here is the smallest number, which is 23. Then the mass is the largest number, which is 50. Then the range is the difference between the mass and the mean, which is 50 minus 23. We get a range, which is 27. Right? Then next is to find the standard deviation. And to find the standard deviation, right, there are steps to look for the standard deviation. The first step is to calculate the deviation of each age, where we have, remember in the ages, we have age 34, 45, 23, and 50. So to get the deviation, we need to subtract the mean from the ages, right? So remember our mean was 38. So it will be 34 minus 38, 45 minus 38, 23 minus 38, and 50 minus 38. And the first one will give us minus 4, the second will give us 7, then the third will give us minus 15, and the fourth will give us what? 12, right? So the second step is to calculate the square division of this. We have to square the deviation, right? Remember our deviation was minus 4, 7, minus 15, 12. So the next step is to square our deviation. Now, 4 minus 4 square will give us 16. Right, 4 times 4 will give us 16. If you do minus is positive, right? So minus 4 square gives us 16. 7 square will give us 49. Minus 15 square will give us 225. And then 12 square will give us 114. Right? So the next thing to do here, right, is to calculate for the variance, where we look at the sum of the square deviation divided by the total number. The sum of the square deviation, right, divided by the total number of the square deviation here. So the sum here is 16 plus 49 plus 225 plus 144 divided by 4, right? 16 plus 49 plus 225 plus 144 divided by 4, right? And if you do this, you get 108.5. So the last step is to get the standard deviation, right? To get the standard deviation is to square the variance, the square root of the variance. So the square root of variance is square root 108.5, which will give us what? 10.5. You can see how we got the standard deviation, right, for that structured data. So the next one we're going to be looking at here, we're going to be looking at how we can be able to solve our first quarter, our second quarter, and our third quarter. So our first quarter is 25%, our second quarter is 50%, and our third quarter is about 70%, right? So this is, remember that for we to solve that, right, the age must be sorted in ascending order: 23, 34, 45 plus 50, right? So to calculate it is the position, which is equal to, right, the position, the percentage, which is 25%, divide in the first quarter is 25%, divide by 100 times the total number of ages we have, which is the n, right? N means the total number of ages, like total number of observations, right? Which is 1, 2, 3, 4, which is 4 plus 1. This is just a formula to do that. Now, looking at the first quarter here, right? The first quarter is 25% quarter, right? So which is 25 divided by 100 times 4 plus 1, which will give us 0.25 times 5 will give 1.25. Now the answer, you can see that based on the formula here, the answer, right, results to 1.25, right? So pushing out these the numbers after the decimal, we have 1. The answer is 1. So this one means that the the this one, you can see this one means that you can see that the position 1.25 in the case Q1 is between what the first and second values in the sorted list. So the one means that the position we're trying to look for is in the first and second, right? One means if number one, so it's in the first and second, right? So the first and second age lies in 23 and the 30. Let's check 23 and 34, right? So using this formula here, so it becomes what 23 plus 0.25. So we have, remember when you take out 1 here, we're left to 0.25, right? So that's how we have 23 plus 0.25 times the second age is 34 minus the first age, right? So if you do this, it will give us, so let's check what will give us here. So calculator. So we have 23 plus 0.25, 23 plus 0.25, then times, remember this is 11, right? So we have 23, right? 23 plus 0.25 times 11. So in board mass, we'll do the multiplication first, right? In board mass, we'll do the multiplication first. So where we have the 23 plus 2.75, which will give you what 25.75. So that is the first quarter. That is the answer to the first quarter. So if you're looking at the second quarter, which is 50%, it's just the same pattern, the same formula where we have 50 over 100 times 4 plus 1 equal to, so we have 2.5. So it means that if you take out this number, right, after a decimal, we have 2. It means that the ages that we're taking out here falls in between the second and the third, right? Called the 2.5, right? Falls between the second and the third. And second and the third is 34 and 45. So if you apply the same formula here, you will get 34 plus 5.5, right? Which is about 39.5. So the same thing applies to the third here, where we get 3.5, which means that the number we're trying to get, right, the age we're trying to get falls in between 3 and 4, right? So do the same thing. Remember, what is left is 0.5. So that's why we have 45 plus 0.5 times the fourth number, the fourth age minus the third age, right? So you get 47. So that is how it works, right? So that is just the basic of descriptive analysis, right? So here in this course, we didn't actually look at exploratory analysis, where we didn't actually look at how we can be able to balance our data set, and we didn't actually look at how we can be able to use the supervised algorithm to actually train our data set to make proper decision, right? So this will be done in our data analysis class, but not in the computer organization. So computer organization class is just highlighting you on the problems involved in analysis and how we can be able to solve that, and just a basic of descriptive analysis to enable you to understand how this works, right? So thank you and God bless you. In the next lectures, we're going to be looking at the main trends in IT and then the impact in the organization. Thank you.